After studying this module, you shall be able to define what artificial intelligence is. We will also know about the history behind it and how artificial intelligence emerged. You will also know about the basics of computerized intelligence. We will also understand the goals of artificial intelligence out here. We people clearly have different conceptions of what it means to be smart. In Western cultures, being smart is typically thought of as having good mental skills that are instrumental to succeeding in school and even in higher level jobs and occupations. In some other culture, it might be being equipped with the ability and the skill to hunt or to know archery. But in a broader perspective, it is the ability to basically acquire knowledge, to think and to reason effectively, and to deal adaptively with the environment. Too complex? In layman language, when we are able to figure out what should be our next move in the game or in chess, that's basically intelligence. If we are careful enough to carry an umbrella when the weather outside requires us to, that too is an intelligence. Did I mention this? What human intelligence is? Is there anything apart from human intelligence that can keep us going? Can machines think? Can we make machines think? Or can they think? All these answers are basically leads to questions which lie on the concept of artificial intelligence. To begin with artificial intelligence, in making a computer, or to begin with, artificial intelligence is making a computer that thinks like a human. So let's first define what is artificial intelligence. Artificial intelligence is also represented as AI. It is an intelligence which is exhibited by machines or software. It is also an academic field of study. Major designs and intelligent agents where it is basically exhibited by machines or softwares. It is also an academic field of study. Major artificial intelligence researchers and textbooks basically define the fields as the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes action that basically maximize its chances of success. John McCarthy, who coined the term in 1955, defines it as the science and engineering of making intelligent machines. The main idea which was behind this is the fact that human intelligence is being used to create machines that can be intelligent, and it is kind of ironic, is it or not. We as researchers are trying to define or trying to take it into a computerized state. Artificial intelligence research is highly technical and specialized and is deeply segregated into subfields and often fail to communicate with each other. The work, what the individual subfields do, the research that is done is often not integrated as a whole. Some of the divisions is due to social and even cultural factors. Subfields have grown up around particular institutions and the work of individual researchers, just as mentioned earlier by us. Artificial intelligence research is also divided by special technical issues. Some subfields basically focus on the solution of their specific problems. Other factors are basically focusing on several possible approaches or the use of particular tool onward towards the accomplishments of particular applications. The research uses a need-based approach. While a particular researcher is basically programming a machine that would be basically on the psychological aspects and developing a machine that can emphasize with or empathize with people. After all, emotional intelligence is a part of intelligence as a whole. We are intelligent if we choose to not punch our bosses in that particular moment of heat. Some of the central problems of artificial intelligence research include reasoning, knowledge, planning, learning, natural language processing, which is your communication, perception, and the ability to move and manipulate objects. General intelligence or strong artificial intelligence is still among the field's long-term goals. Currently, popular approaches basically includes your statistical methods, computational intelligence, and traditional symbolic artificial intelligence. There are a large number of tools which are being used in artificial intelligence, and including versions of search and mathematical optimizations, which would be your logic methods based on probability and economics and many others. Artificial intelligence fields basically are interdisciplinary, in which a number of science and professions converge, including computer science, psychology, linguistics, philosophy, and neuroscience, as well as other specialized fields such as artificial psychology. The field was founded on the claim that a central property of humans' intelligence basically can be so precisely described as a machine. The sapience of Homo sapiens can be so precisely described that a machine can be made to stimulate it. This raises philosophical issues about the nature of the mind and the ethics of creating artificials being endowed with human-like intelligence, issues which have been addressed by myth, fictions, and philosophy since antiquity. Artificial intelligence has been the subject of tremendous optimism, but has also even suffered stunning setbacks. Today, it has become an essential part of the technology industry, providing the heavy lifting for many of the most challenging problems in computer science. Now let's see from where it has emerged the history of artificial intelligence. Thinking machines and artificial beings appear in Greek myths. Human-likeness, believed to have intelligence, were built in every major civilizations by the 19th and the 20th century. Artificial beings have become a common feature in action, as in Mary Shelley's Frankenstein. Stories of these creatures and their fates discuss many of the same hopes, fears, and ethical concerns that are presented by artificial intelligence. Mechanical or formal reasoning has been developed by philosophers and mathematicians since antiquity. The study of logic led directly to the invention of digital electronic computer based on the work of mathematicians, Alan Turing and others. Turing's theory of computation suggested that a machine, by shuffling symbols as simple as 0 and 1, could simulate any convincible act of mathematical deductions. You present your trouble to the computer, and it will process it in the combinations of 0 and 1, but ultimately convert its result by or able to see the solution in some language in which you have presented the problem. This, along with concurrent discoveries in neurology, information technology, or theory, inspired a small group of researchers to begin to seriously consider the possibility of building an electronic brain. The field of artificial intelligence research was founded at a conference on the campus of Dartmouth College in the summer of 1956. The attendees, including John McCarthy, even there were other people also, which were Marvin Minsky, Alan Hewell, and Herbert Simon, became the leaders of artificial intelligence research for many decades. They and their students wrote programs that were to most people simply astonishing, Computers were solving word problems in algebra, providing logical theorems, and speaking English. Computers were communicating like humans. By the middle of the 1960s, research in the US was heavily funded by the Departments of Defense, and laboratories had been established around the world. Artificial intelligence founders were profoundly optimistic about the future of the new field. Herbert Simon predicted that machines will be capable within 20 years of doing any work a man can do. Marvin Minsky argued or agreed, writing that within a generation, the problem of creating artificial intelligence will be substantially be resolved. They had failed to recognize the difficulty of some of the problems they faced. In 1974, in response to criticism of Sir James and ongoing pressure from the US Congress to fund more projects, both the US and the British governments basically cut off all undirected exploratory research in artificial intelligence. The next few years would later be called an artificial intelligence winter, a period when funding for artificial intelligence projects was hard to find. In the 21st century, artificial intelligence has basically achieved its greatest success. Alibaba was basically somewhat behind the scenes. Artificial intelligence is used for logistics, data mining, medical diagnosis, and many other areas throughout the technology industry. It's an ever-growing field, and it is able to basically actually capture or appreciate the rate at which it is growing. We get to expand the horizon of our minds as well. The success was due to several factors: the increasing computational power computers, a greater emphasis on solving specific sub-problems, the creation of new ties between artificial intelligence and other fields working on similar problems, and a new commitment by researchers to solid mathematical methods and rigorous scientific standards. We could also say that there were other people also who had basically given their work out here. On 11th May 1997, Deep Blue became the first computer chess playing system to beat the world chess champion Garry Kasparov. Now let's understand the computerized intelligence. The goals of computerized intelligence. The general problem of stimulating intelligence has been broken down into a number of specific sub-problems. The reason being addressing all the problems at one go would be like to basically an unfruitful effort. These consist of particular traits or capabilities that researchers would like an intelligent system to display. The traits described below have received the most attention, and these are your deduction, reasoning, and problem solving. The most appreciated concern, effort in the field of artificial intelligence research has been creating an intelligent machine which can basically address problems and assess the reasoning as well. Early artificial intelligence researchers developed algorithms and imitated the step-by-step reasoning that humans use when they solve problems or puzzles or even make logical deductions. By late 1980s and 1990s, artificial intelligence research has also even displayed highly successful methods for dealing with uncertain, incomplete informations, employing concepts from probability and even economics. So, as even mentioned earlier, artificial intelligence research is multidisciplinary and not just count to mechanical engineering, and it also involves and even appreciates inputs from various disciplines. Human beings solve most of their problems using fast, intuitive judgments and even rather than conscious, step-by-step deductions that early artificial intelligence research was able to model. Consider this example. Suppose you are traveling by car and unfortunately you get a flat tire. The step-by-step deduction would demand you to call a mechanic and search for a solution, whereas working according to the intuitive judgment would enable you to change the tire yourself. Artificial intelligence has made progress and at initiating this kind of sub-symbolic problem solving. Embodied agent approaches emphasize the importance of sensory motor skills to higher reasoning, neural set search attempts to stimulate the structures inside the brain and that give rise to skill, statistical approach to artificial intelligence, and even mimic the probabilistic nature of human ability to success. Knowledge could be represented in a form which you can see in a diagram or in the concept also. Knowledge representations and knowledge engineering are central to artificial intelligence research. Many of the problems machines are expected to solve will require extensive knowledge about the world. How would you change the tire if you are unaware of the skill required to do it? Among the things that artificial intelligence needs to represent are objects, properties, categories, and relations among objects, situations, events, states, and even time, and also the cause and effect, knowledge about knowledge, and even many other less well-researched domains. A representation of what exists is an ontology. The subject, the set of objects, relations, concepts, and so that the machines knows about it. The most general are called upper ontologies, which attempt to basically provide a foundation for all other knowledge. Among the most difficult problems in knowledge representations are default reasoning and the qualification problems. Many of the things people know take the form of working assumptions. For example, if a bird comes up in conversation, people typically picture an animal that is fur-sized, sings, and even flies. None of these things are true about all the birds. John McCarthy identified this problem in 1969 as the qualification problem. For this rule, artificial intelligence research care to represent for tend to be a huge number of exceptions. Almost nothing as simply true or false is the way with or that abstract logic requires. Artificial intelligence basically research has explored a number of solutions to this problem. The breadth of common sense of knowledge is also there. The number of atomic facts that the average person knows is astronomical. Research projects that attempt to build a complete knowledge base of common sense knowledge requires enormous amount of laborious and ontological engineering. They must be built by hand, one complicated concept at a time. A major goal is to have the computer and understand enough concepts to able to learn by reading from sources like the internet and thus be able to add to its ontology. The sub-symbolic form of some common sense of knowledge are much of what people know is not represented as facts or statements that they could express verbally. For example, a chess master will avoid a particular chess position because it feels too exposed, or an art critic can take one look at a statue and instantly realize that it is a fake. Intuition, the ability to acquire knowledge without interference or the use of reason, comes naturally with intelligence. While traveling by public transport, if someone is constantly staring at you or your back, you get an intuition. This is included in intelligence. These are intuitions or tendencies that are represented in the brain non-consciously and sub-symbolically. Planning is another aspect of computerized intelligence. A hierarchical control is being shown which displays about the control system in which a set of devices are governing software as arranged in a hierarchy. Intelligent agents must be able to set goals and achieve them. They need a way to visualize the future and to be able to make choices that can basically maximize the utility of the available choices. In classical planning problems, the agent can assume that it is the only thing acting on the world and it can be certain with the consequences of its actions may be. However, if the agent is not the only actor, it must particularly ascertain whether the world matches its representations or predictions, and it must change its plan as this becomes necessary, requiring the agent to basically reason under certainty. Learning. Machine learning is the study of computer algorithms that improve automatically and even through experience and being central to artificial intelligence. Research since the fields of inspection in summer 1956. Unsupervised learning is the ability to find patterns in a stream of input. Supervised learning basically includes both classifications and numerical regressions. Classification is used to determine what category something belongs in after seeing a number of examples of things from several categories. For example, A, B or A and B are blood types. Regression is an attempt to produce a function that describes the relationships basically between inputs and outputs and predicts how the outputs should change as the inputs change. These can be analyzed in terms of decision theory using concepts like utility. Natural language processing gives machines the ability to basically read and comprehend the language that humans can speak. A sufficiently powerful natural language basically processing system would enable natural language users to interface with the acquisition of knowledge directly from human written sources such as news via text. Some straightforward applications of natural language processing include information retrieval and machine translations. Imagine if blind people could have a machine capable of basically reading for them. A common method of processing and extracting meaning from natural language is through semantic indexing. Increases the processing speeds, and the drop in the cost of data storage makes indexing large volumes of abstractions of the user's input much more efficient. Perception. Machine perceptions is the ability to basically input from sensors as cameras, microphones, and to deduce aspects of the world. Computer visions is the ability to basically analyze visual input. Motions and manipulations. The field of robotics is closely related to artificial intelligence. Intelligence is basically required for robots to be able to handle such tasks as object manipulations and navigations, with some problems or sub-problems of localizations, mapping and motion planning, path planning, all these things. In layman's language, a robot serving water to the guest at home. Long-term goals would be, among the long-term goals in the research pertaining to artificial intelligence are social intelligence, creativity, and general intelligence. So what would be social intelligence out here? Social intelligent effective computing is the study of development of analysis or a development of systems and devices that can basically recognize, interpret, process, and stimulate human effects. It also includes creating intelligent agents capable of maintaining social order. It is an interdisciplinary field spanning computer science, psychology, and even cognitive science, with the origin of its field to be traced as far back as early computer science originated with Picard's 1995 paper on active computing. Emotions and social skills also play two roles for an intelligent agent. First, it must be able to predict the actions of others by understanding their motives. It can also understand their emotional states. For example, if you are fighting with an intelligent agent, it should be able to predict at what stage of the argument you're going to get violent and run to destroy it. Also, in an effort to facilitate human-computer interactions, an intelligent machine might want to be able to display emotions, even if it's not actually experienced them itself. In order to appear sensitive, it can also display emotional dynamics of human interactions also. Creativity, A subfield of artificial intelligence also addresses creativity out here, both theoretically and even practically. Then is your general intelligence. Many researchers think that their work will eventually be incorporated into a machine with general intelligence, combining all the skills above and exceeding human abilities at most for all of them. Few believe that artificial consciousness is an artificial brain may be required for such kind of a project. So in order to solve all the problems, you must solve the problems in a complete manner. When we have gone through this module, there would be certain points which we would like to relook. That is the summary of this module. Artificial intelligence was basically an intelligence exhibited by machines or softwares, the term which was coined by John McCarthy in 1955, who defined it as the science and engineering of making intelligent machines. The field of artificial intelligence research was also founded at the conference on the campus, Dartmouth College, in the summer of 1956. Some of the goals of artificial intelligence basically include deduction, reasoning, problem solving. The most appreciated effort of artificial intelligence research has been creating an intelligent machines which can address basically problems and assess the reasoning as well. Knowledge representations was also an ontology, represents knowledge as a concept within the domain and the relationship between those concepts. Planning was also intelligent agent must be able to get or set goals and achieve them. Learning intelligent agents should be able to learn the new information they come across. Last but not the least, we had discussed about natural language processing, which gives the machines the ability to read and comprehend the languages that humans basically speak.